Hello and good anytime. In this tutorial, we will learn about a common electronic device called the LED, which stands for the light emitting diode. LED na a kind of electronic device where their work na for give out visible light, or when this device receive light from any other source, it will equally produce a certain small voltage for its terminals. Therefore, LEDs, also called LED, na a type of semiconductor called in full the light emitting diode, will be abbreviated as LED. The light emitting diode na some kind of semiconductor light sources wey dey combine a p-type semiconductor, that's the larger holes concentrations, with an n-type semiconductor, that's the larger electrons concentration. If we apply a sufficient forward voltage, this will cause the electrons and holes to recombine at the p-n junction, and this will release energy in the form of light particles. Where for the big chemistry word, these light particles are called photons. Now, if we want to compare the conventional light source, we go first convert the electrical energy into heat energy, and then after go convert that heat energy into the light source. But LEDs, that is the light emitting diodes, go directly convert the electrical energy into light energy, delivering efficient light generation with very little waste in electricity. So in their type, we get two types of LEDs available in use: the lamp or the leaded LEDs and the SMD LED chips, and they are different than for their mounting process. The leaded LEDs type be mounted by the through hole method, and SMD, this other type, be mounted on the surface of the circuit board. Now, when we apply a voltage across an LED, this will produce light. This light dey occur from a tiny piece of semiconductor material wey dey inside the epoxy case or inside the LED, go emit energy as photons, that is the visible wavelength. This epoxy na the material wey dey use am, some resin na some material wey dem dey call am resin, na dey use am for mold this case for protect the semiconductor material wey dey produce the light wey we dey see am, wey na dey give out that energy as photons, wey be the visible wavelength, wey na the light wey we fit see am. But if we shine a light on the LED, like on the picture wey we dey see am now, this means say we dey apply or shooting photons or applying light energy back into the LED. Then the process go reverse, meaning say at the anode and cathode of this LED, if we measure its terminals, the LED will produce some small voltage value. So LEDs look something like this. They come in different shapes, colors, and size for different applications. We go use this symbol for the engineering drawing for LEDs as its circuit symbol. So this drawing we will get on our board, they represent the schematic symbol of an LED. If we get the symbol like this, or if we still get them like this, sometimes you will get this arrow. This arrow will still be for outside here, no problem. Will still be for here, no problem. But the position for this arrow must always be against the direction of electron flow. Since we know say electron they flow from negative to positive, so the direction for this arrow will always be against the direction of electrons. So whenever you draw this symbol, you must always respect this sign. And you fit notice it is very similar to a normal diode symbol, except for those two arrows wey go indicate say the component dey emit light. So LEDs and diodes both get the same working principles. Na just a semiconductor material inside the middle of some electrical connectors, and both of them go emit photons. But na only the LED dey emit photons in the range visible to human eyes. And that is now when the photons get a wavelength of around 400 to 700 nanometers. We fit see different colors depending on the wavelength of the photons in this range. For example, the FM radio signal na also a photon wave, but it dey around 3 meters. The Wi-Fi signal too, but it be too small, around 6 meters. And a medical X-ray be very tiny at around 0.01 nanometers. But we no fit see any of these photons because they be out of our visible spectrum. Now, a good example na our TV remote control. This remote get an LED wey dey emit infrared light with the photons having a wavelength typically around 940 nanometers. So our eyes no fit see this infrared light. However, you fit see it on the camera of your phone. Which means if you take your phone, you point them under the camera for, you take your telecommand, then you point them under the camera for your phone. While pressing any button, from there you will fit see the infrared light. So therefore, inside semiconductor materials, we just get electrons wey go combine with holes and releasing photons in that process. Now, a standard diode uses different materials in its semiconductor region or layer, which produces photons in the near infrared range. These photons be absorbed by the casing of the normal diode and converting that photons to heat energy. Now, why that diode then diode during their working process. Because the only way for say that heat wey they produce for dissipate na through the body of that of their casing. And you know say when current dey pass or when electric current dey pass through any conductor, it dey produce heat because electric current dey pass with friction. That's the electrons dem dey get friction amongst them. The more faster wey dey pass, na so the friction wey dey produce, and then e dey give heat. Na why that way you go look some cables dey hot because that cable no fit resist the amount or the frequency, the speedness for the current wey dey pass for that cable. The cable small. So whenever you use any cable or you see any cable wey dey warm, know say that cable no correct for that particular use wey the cable dey work for that moment. If the cable dey hot, means e no correct. You get for change and use big cable. So the only way for a normal diode for dissipate heat na on the body. But for diode, the only way it dey give am like light. So na just the difference that way dey between a normal silicon diode with a light emitting diode. Light emitting diode will give you light, but the normal diode get its own purpose wey e dey work. That's for make current go through one direction, and then for block the negative current for make the positive current pass. But LEDs they produce very little heat as compared to the traditional incandescent light bulb wey go generate a lot of heat. In the incandescent or in the traditional incandescent light bulb, the electrons then go collide with the atoms in the filament made of tungsten, for example, and this collision go produce heat. The filament go heat up so much that it go produce visible light. LEDs no dey produce heat before light, and so they be much more efficient in terms of energy. I be very convinced say una go recognize this type of LED. Na a 5mm through holes type. But you don't ever notice say one side get a flat edge. This type of LED be perfect for learning electronics because you fit insert them in a portable breadboard, and it be very easier for soldered onto a circuit printed board. We also get the second type wey na the SMDs, meaning surface mount devices. This type of LED dem be too small wey we go solder them on the surface of a circuit board in order to allow create compact designs or models. For example, we go usually find SMDs used in our light bulbs, our TV screen backlight, often used for modern car flashes, or used for our torches and flock light. That's the LED road projectors, traffic light, and decorations, and so on. LEDs they exist in various different color lenses, but we fit also get transparent version which go emit different color light too. The cases of an LEDs be colored to make it easier for us to tell what color light will be produced. Now actually just that material inside the semiconductor layer or region wey go produce these different colors of light, and not the